Good morning, calculus students. I'm going to walk you through problem number 1 from that worksheet from class. So we had g of x is the function 1 over square root of x, and we were supposed to find g prime of 1 using the definition of the derivative at a point. So I'm going to do it both ways. Remember, there were two different ways we could do it. So the first way is using g prime of the number a is the limit as x approaches a of g of x minus g of a over x minus a. And so in this particular problem, a is the number 1. So what we're going to do is g prime of 1 is going to be the limit as x approaches 1 of g of x, which is 1 over square root of x, minus g of 1, which is 1 over square root of 1, over x minus 1. So now we can see if we plug in x equals 1, we get in the numerator 1 over 1 minus 1 over 1, and in the denominator we get 1 minus 1, so we get 0 over 0. And that's an indeterminate form. We don't know what it's going to be. So we have to do algebra to simplify it and try to get rid of the problem. So what we have here is a complex fraction, and the quickest way to simplify a complex fraction, or to make it not complex anymore, is to multiply and divide by the least common denominator of all the fractions that you have. Well, you really only have one fraction. You have 1 over square root of x, because 1 over the square root of 1 is just 1. So the least common denominator of all the fractions in this big old complex fraction, the least common denominator is square root of x. So let's multiply and divide by the square root of x. And then what we get now in the top, when you multiply across by square root of x, you get 1 minus the square root of x. And in the bottom, we're just going to leave it factored. All right, notice I had to write the limit as x approaches 1 because we haven't taken the limit yet. So now what we have is a rational expression, and the numerator, lucky for us, is a difference, 1 minus the square root of something. And as you saw in one of the previous videos, the way we deal with that is by multiplying and dividing by the conjugate of that expression. So let's multiply by 1 plus the square root of x, and also divide by that same thing. Now, when we multiply across, so we've got the limit as x approaches 1. So notice in the numerator, you've got a minus b times a plus b. And a minus b times a plus b is always a squared minus b squared. It always turns out to be the difference of squares. So it's the numerator is now 1 squared minus that square root squared, which is just 1 minus x. The denominator, we're just going to leave it factored. It looks messier, but it's going to be okay. Now check out what we have. In the numerator, we have a 1 minus x. In the denominator, we have a product, and one of the factors in that product is x minus 1. 1 minus x and x minus 1 aren't quite the same, but they're almost the same. They're just opposites of each other. So I'm going to rewrite the numerator. So we have the limit as x approaches 1 of, and now in the numerator, I'm going to factor out a negative 1 from both terms. So I can write it as the opposite of x minus 1. That's the numerator, just with the minus 1 factored out. And then the denominator stays the same, but check it out. We've got some cancellation we can do there. So now let's rewrite it. It's the limit as x approaches 1 of negative 1 over square root of x times 1 plus square root of x. Now, check if we can plug in x equals 1. And it looks like if we plug in x equals 1, we don't have a 0 in the denominator anymore. So let's plug it in, and we get negative 1 over square root of 1 times 1 plus square root of 1. And this is just going to be negative 1/2. So that was a lot of algebra, but it's the kind of algebra that you're going to see a lot in this course. Let's do the same problem using the other definition. Okay, so this time we're going to use g prime of a is equal to the limit as h approaches 0 of g of a plus h minus g of a all over h. And in our problem, a is 1 again. So we're going to find g prime of 1, which is the limit as h approaches 0 of g of 1 plus h, so that's 1 over square root of 1 plus h, minus g of 1, so that's 1 over square root of 1. And that's all over h. So we're basically going to do the same algebra we did before. The first thing I want to do is kind of simplify the complex fraction. So looking at the complex fraction, I look at all the fractions within the fraction, and I want to find the least common denominator of all those fractions. Well, really the only fraction I have is 1 over square root of 1 plus h, because the other fraction is just 1. So I'm going to multiply and divide by that denominator, square root of 1 plus h. That's the least common denominator, so I'm multiplying the top and the bottom of the big complex fraction by that least common denominator. And so then I have the limit as h approaches 0, and now the numerator, when I multiply across by the square root of 1 plus h, I get 1 minus the square root of 1 plus h. And then in the denominator, I leave it factored. So once again, we have this radical expression, and we've got a difference in the numerator, and we know how to deal with that. We multiply and divide by the conjugate of that numerator. So I'm going to multiply by 1 plus the square root of 1 plus h, and then I also have to divide by the same thing. So when I do that, I still have the lim as h approaches 0. Now we have an a minus b times an a plus b in the numerator, so that's always a squared minus b squared, so it's 1 minus the square root squared, so it's 1 minus 1 plus h in the numerator. The denominator is just left factored. So now check it out. If I simplify the numerator, I have 1 minus 1 minus h. Well, 1 minus 1 is 0, so I'm just left with minus h. And then the denominator stays the same. But check it out. We got some cancellation we can do here. Boom, boom. And what we're left with is the limit as h approaches 0 of negative 1 over square root of 1 plus h times 1 plus square root of 1 plus h. Now, can we plug in h equals 0? Yes. We don't have a 0 in the denominator or in the numerator, so we can go ahead and plug it in. So we don't have to write limit anymore. So we have negative 1 over square root of 1 times 1 plus square root of 1, which is negative 1 over 2, and we get the same answer. All right, so in your section 2.7 homework, you're going to be doing a lot of problems with algebra very similar to this, and you're going to get really good at it. Okay, I'll see you in the next video.